Right, so I haven't shown you the first thing real quick. It's the opposite angle identities. You know, you've seen it. I've actually heard you say this. It's just formalizing it now. Okay, so let me ask you this. What is the cosine at negative pi over 4? Okay, let's go here. What's the cosine of pi over 4?
Yeah, that. Cosine root 2 over 2.
Okay. So we're thinking, you're on the unit circle, you know this one, right? That's pi over 4.
Yeah.
Okay, negative pi over 4 is right here. Are they the same?
No. Yes.
Yes.
Yes, they are. Okay. Same x value, right? This x value is the same for both of them. Right. Oh, hey, look at that. They're equal. Okay, so this is an opposite angle identity. The cosine of some negative angle is the same as the cosine of the opposite of that. Right. So if you're looking for the cosine of negative pi over 4, it's the same as cosine pi over 4. And you can use that to your advantage. Okay.
When I look it up, it says the cosine. So it's negative. It's the same one, but on this it says it's 7 pi over 2.
It's the same thing. Negative pi over 4 versus 7 pi over 4.
Oh.
Right? Yeah, same thing.
Oh.
Okay.
Is that in a parentheses and a flesh on the bottom? Or what is that theta?
Yeah, it is. Okay, so cosine is what we call an even function, and that's what generates this. Okay. How about sine? At negative pi over 4.
That is negative root 2 over 2.
Yeah, it is. Okay, and sine at pi over 4 is? Sine at pi over 4? Say it louder.
Root 2 over 2.
There you go. Okay, yep, I'm deaf, I'm a woodshop teacher. Thank you for dealing with that. What do you notice? Yeah, they are opposites, right? So if I have the sine of some negative angle, it's the negative of this. Okay. Little strategy to use. Again, you're using quadrant 1 here for the most part. That will help you solve problems in other quadrants. They're called opposite angle identities. Yes, Mr. Jansen.
You just answered the question.
That's his father.
Is that a negative sign with theta?
Mm-hmm.
But then why doesn't it say that on the top? Like.
Okay, here is the sign at negative theta gives a negative output.
Okay.
Right. I just illustrated that with the positive gives a positive output.
So why is there a negative in front of the sign?
Here,
Yeah.
because it gives a negative output.
But
The
that's
negative
not-
angle gives a negative output. You're not satisfied, that's fine. Here's another way to think about it. If I have sine of pi over 4, root 2 over 2, Okay, what is the sign at negative power 4?
Negative.
Negative root 2 over 2.
I just don't.
The point is that if you have opposite angles, so negative power 4 and power 4, they differ by a sign. Okay. In order to solve this problem right here, you can use sine power 4's information, but you have to know that it's going to be a negative. That's what this identity is telling us. Okay. Here's the meat of today. This is simplifying trig expressions. That's an eraser. This is our first step in solving trig equations. So if I have something like this, I already forgot this. Bless you. It's very cute. Okay. All the boys laughed. I think I insulted everyone. Okay, this is an expression. What we're headed towards in the end is putting this equal to something and making it an equation and solving for x. Okay, but right now we're just practicing making these more simple. Okay, there are a few tips that I can give you. Okay, the number one tip you're going to use on these to simplify them is change everything to sine and cosine. Okay, so tips. Change to sine and cosine. Okay, is there something in here I can change to sine or? Okay. What is cotangent in terms of?
It is
over
1.
In terms of sine and cosine, we had an identity a couple days ago.
Cosine or sine.
It is cosine squared over sine squared, because it's a squared cotangent, right?
Is that sine x plus sine x times?
Yeah. I put this in red because I changed it.
What does the square do to it? So sine squared, what does that do to it?
I don't even know what they do.
It squares the answer. Okay, right. Okay. What can I do with that? How? Can you see it?
2 sine x.
Nope, these are attached, so we can't add those yet.
Oh, that's true.
Okay, do you have 2 fractions, right?
Yeah.
Can I cancel a sign out?
Yeah.
So I can cancel that sine x
Yeah.
and one of these, correct?
Yeah.
Because there are 2 of them.
Oh.
So what I end up with here now is cosine squared over sine. Okay, sine x. And then what have I done there? I've done some fraction math. Okay, and we're going to come back to that again. So you've just simplified a fractions, multiply them, right? So that's another thing you're going to do quite a bit with these. If you want to be technical, changing to sine and cosine is using identities. We'll put that one again. Okay, how can I get it to the point where I can add those together?
Multiply by sine x on the side.
Or divide.
Yeah, I have to change this to a fraction, right?
Oh. So divide by sine.
With a common denominator.
Yeah.
Yeah. So I am going to multiply the common denominator is sine x.
Yeah.
Okay, and then so what do we end up with on top?
Sine x squared.
Sine, yep, squared x over sine x
So it can be sine.
plus this. Okay. But again, we've done more fraction math, right? Okay.
Sweet.
Now I can combine these, so I'm going to write them as one, just so you see it. There's one more step. 2 steps and we're done.
Well, when you divide, so doesn't that turn into sine x plus cosine square x?
There was an identity last week called the Pythagorean Identity. What is that equivalent to? Sine squared plus cosine squared is?
That's, tangent, or tangent.
1.
That's, okay.
Yep. It's an identity.
So it's 1 over.
If you look back to your notes from Friday, I think it was. Sine squared plus cosine squared is 1. Okay. So you have just used an identity. Okay. That's the third tip I can give you.
What's sine squared plus tangent squared?
Sine squared plus tangent squared.
Yeah.
There's no identity for that. So change to sine and cosine. We did some fraction math. We've used an identity. But we're going to use another identity to finish it off. What is 1 over sine equivalent to? 1 over sine x. It's a reciprocal identity.
Sine x over 1.
Those are not the same.
It's equal to
Somebody said it.
cos.
What's that called?
Cosecant.
Cosecant. Cosec. Cosuck. Cosecant, right? There's your finalized, simplified expression.
Wow,
It's a lot of work, isn't it? Okay, that one was a little bit longer, but I use it because it shows some of the tips I can give you, right? All of these are in it, so I wanted to make sure you had that in your pocketbook.
So that's like I said, real.
Do you want to see another one? No?
They're in that group. You know what I do? I open the exercise. That's all I do.
I didn't assign anything in 44 through 53, right?
No.
Okay. So let's try one of those.
Feels so bad.
Simplify. Stupefy. I gave you some tips on the last one. Yeah, change to sine and cosine. First thing you do. Most of the time that'll help. There are very rare times where it won't. Okay, so what is secant?
1 over
Sine.
1 over cosine.
Cosine.
That is dumb. Whoever did it that way is not smart.
Whoever did it that way is a lot smarter than every single one of us.
That is true, but their thinking of that was not smart.
Tangent.
Yeah,
One
sine all
over-
costs.
Thank you, Paul.
Yeah.
Sine over.
In terms of sine and cosine.
Cosec again.
Okay?
It's cosec. Yeah.
Oh, yeah.
So we have, okay, so your tip here, change to sine and cosine, right?
That turned into 1 over sine x.
So it's cosec.
Okay, what can I do next?
You could eliminate the cosine x. Both sides.
Yeah, you can. What's your What tip am I using on that one? If we go back to slide 1.
Fraction math?
Yeah, you're doing fraction math here. So I'm going to copy, dot, and flip.
Copy dot flop.
That's fraction math,
Yes,
right?
it's cosec again.
So they cancel out and it equals 1 over sin x.
Yes.
So the cosines can,
Cancel.
boom, boom.
1 over sin x, which equals secant, or cosecant.
1 over sin x.
Yeah, 1 over sin x is
CSC.
cosecant. Here we've used more fraction math, right?
Yes.
Okay, here we are using an identity.
Yeah. I know I would know.
Okay. So again, another one that we've used all 3 of those tips.
Basically like saying, oh, this is equal to this.
So that one's a little shorter, right?
1 over is equal.
And in reality, at this point, you don't have to write this step if you don't want to, but again, one of the best things for you to do on these is to stay nice and neat and organized. Some of you boys have issues with that. Step by step, it's okay to use paper to go vertically. You can go horizontally too, but be organized. You're going to lose yourself in the muck. Kellen.
Well, the Calc AP test, would they tell you?
These aren't on the Calc AP test.
Huh?
We don't do much of this on the calculus AP test.
Oh, but if we did have a test of some sort,
Oh,
would
if
it,
we had a test.
yeah, would it expect you to know that, or would it give you like a thing that says 1 over sin x is CSC?
For calculus, you get nothing
Ooh.
for the AP exam.
Ooh. Okay.
In here, you get your blue sheet. But it's very rare that we do this. If we do this, it's these.
Yeah.
Okay, in calculus. We use this to solve trig equations. Okay, so basically what we're building up to is being able to solve something like, when is this true? Okay, solve for the value of x. And if we can solve for the value of x using calculus, we can find maximum, we can find the minimum, we can find critical points, concavity, we can do all sorts of neat stuff. Okay?
Is that an identity or is that a-
No, that's just an equation. This is where we're headed with this, is solving these. Okay? But you have to be able to simplify trig expressions to solve these. So this is our end game. Okay? All right, that's an easier example, and then the harder example I showed you before. No, that was more of a medium. You can get really, really, really nasty on these. Take out time. See what yeah, the ones I assigned you are easy, medium, no, mostly easy, so it'll be good. We'll continue to work on the next 2 days. Is the same as verifying trig identities, so we're going to be doing this stuff a lot. Okay. I think the assignment is 14 through 17.
Oh, it's 14, 17?
Yep. It's 4 of these.
That's easy.
Okay, so
Tomorrow?
yeah. So get a little practice in there of those and bring questions. Because we're gonna continue working on them all week. We're gonna add an equal sign in there at some point. There you go.